Hello friends, today we are going to design footing in RCDC. As we have seen design of column in our last video, we are continuing the footing design for the same project. As you can see, the first interface from the RCDC, you have to put your name, project name, and you have to select design code. We are selecting IS 456 and IS 13920-2016. Now you have to import your project from STAD or ETAB. For this we have created already the MDB file from ETAB, so select that MDB file and open. Now select the option for footing. As we are designing footing, now click on create new project. As you can see, we have imported MDB file successfully, and the column layout for our project this is showing column numbers. You can see the column numbers. Now we have to define some parameters. You can see here the column numbers and the footing numbers. First thing to do, we have to import our column sizes from our already designed column file. So that we have to go in here, import column data. Now you can see this is our column file, so click on open. As you can see, it will import column size and column marks from our previous file. Now in setting, first is general setting. In general setting we have to change as per our project details and our specifications. First is a design setting. You can see here so many options: gross SPC, consider overburden, surcharge, checkpoint C, and the sliding. In this video we are designing the footing for RCC building, so I will explain in next video when we are going to considering overburden, gross SPC and surcharge loads. For this we just keep all these options unchecked. Now the second option is soil data. Now we have to put our SBC data from our geotechnical report. We have to put SBC. I am putting here 300 kN per square meter. We are taking 300, the constant value from our geotechnical report. Next is soil density, as we are keeping as it is. Next is founding depth. For founding depth, this is the depth of foundation from the ground level, so we have to give the foundation depth from ground level. From this foundation depth it will calculate the soil load as overburden, but in this footing design we have not considered overburden, so it will not consider the soil overburden in the design. In next video, when we design the footing for overburden, we will explain the soil weight. So for founding depth, I am considering 1.5 meter from ground level. In our case, there is no water table. In RCDC, the water table in meter is considered from ground level also. So if in the geotechnical report there is no water table, then we have to put the depth of water table more than our founding depth. So we are putting the same value as the founding depth. We can put the value for permissible loss of contact as per our code. Sometimes it will be 25% as per our code, but we are keeping as it is. The next is design parameters. We can change the design parameter such as concrete grade. In our case, we are putting M25. Next is steel grade. You can add, if you want some more options, you can add the grade of concrete and grade of steel in this box and click OK. Now we are putting same as it is, M25 and grade of steel Fe 500. Next is clear cover. Clear cover for footing we are taking 50 mm. Live load reduction 50%. We are keeping it as it is. Type of soil. In our case, our type of soil is medium, so we are taking this also as it is. SBC increase in earthquake. As per the code, the value 20% increase in earthquake. So these two values we are keeping all as it is. Then the next option is PCC thickness. We can define the PCC thickness. The PCC thickness and the PCC offset, it will appear in our drawings also. So we are keeping 150 depth of PCC and the offset of the PCC from the footing face. The next is dimensional settings. You can set the dimensional setting as per our drawing requirements. If the depth of footings we have to round up, in some time it will shows the odd values, so avoid this. We can set the predefined multiples so that it will show the footing dimension, such as footing dimension and depth in the multiple of 50. So we are keeping this 50, and for depth we can select 25 or 50 in the multiple of 50 or 25. The next is for the step footing, the maximum number of steps, the maximum depth and minimum depth. The minimum depth, sometimes it will not require, some footings will show less depths, so we have to give the specific minimum depth for some footings. You can set the minimum depth as per your requirements. The next is plan limits. You can set your plan limits, but we are going to keep as it is. And the next is cross section design. We are keeping this average pressure. Then click on OK. Next is reinforcement setting. As you can see, the reinforcement, we can set the reinforcement as per code. As we have selected the Indian code, it will take all the values, default values. As you know that minimum percentage of footing or all the values it will take from the code. And rebar spacing, you can set the rebar spacing, the minimum value, maximum values, and the preferred spacing as in 100 or minimum shear steel or maximum shear steel. You can set the spacing round up in multiple of 5, 10, 15, or you can change this in as per your requirements. The next is rebar. First is main steel, minimum bottom steel. We are keeping 10 mm. The minimum top steel, this will also we are keeping 10 mm. The maximum steel, we can change the maximum steel, but now we are taking same. So the next is shear steel. We are keeping all the values same. The next is rebar diameter. You can select your required diameter for the design. If you don't want the higher diameter, you can unselect the higher diameters and then click on OK. As you have unselected the higher diameters, you have to change the diameter here also. The maximum diameter we have set is 20, so we have to set the maximum diameter 20 in all the options. Now click on OK. The next is detailing. You can set the detailing as per your requirement. The fixed distance as the vertical leg of the bottom reinforcement, you can change as per your requirement. Top steel vertical leg or face reinforcement, SFR spacing, or your level description, and the drawing scale. We change the drawing scale as 1 as to 50. The next is rebar mark manager. You can set the mark manager, it will appear in your drawing. So you have to select the rebar mark manager. We are selecting this format. You can change as per your requirement. It will appear, as you can see in the preview, it will appear like this on our drawings. The next same for the shear reinforcement and also for SFR. It will appear here, you can see the in preview, it will appear on the drawings. So we will see this in our drawing also later. Okay. The next is crack width. As per the codal value, you can select the crack width checking. In this case, we are not designing or checking the crack width. I will keep as it is. The next is load cases. The same procedure as we have seen in the column design, we have to select all the load cases as we have seen in the previous video, but now I am importing the same settings from the last design file. For that, you can select one by one, or you can import your predefined cases and combinations from here. Click on the import case and combination, and you have to export first. I will show you how to export the load combinations. It will create this file. You have to open just this file, and then you can see all the load cases are appeared here and also selected the previous load combination. Then just click on OK, as you can see, it has also imported the load combination also and for sizing also. So it will reduce your time for selecting the load cases and combination. Then just click on OK. Now we have done all the settings, so we can start design our footing. For that you can select here the auto design, or from the design, the auto design tab, just click it. It will take some time. You can see progress here. So you can see our design is ready. As you can see, all the footings are ready. Here the output for the footing design, you can see here the number of footing number, column number, the type of footing, material, size of columns and footing size. You can see here the reinforcement for the footing. The top we have not provided top reinforcement, so you can see only reinforcement, bottom reinforcement here. Here for some footing there is required top reinforcement also. We can see one by one. Now for our study we are going to design the individual footing. We will check the design for a single footing. We can, in this, for this we are selecting this footing. Okay, let's click here, or click on right click and then design, or click here and click on design. As you can see here the design tab is open. Now you can also change the settings for individual footing from here. Here we can see the redesign option, then the reset option, and then the view design settings. If you click on this, you can see the settings we have done previously in the starting. So you can change some values for individual footings also from this. We are not changing for this footing. Then next is footing. You can see here it will showing the footing mark, then footing type. You can change the footing type here, what type of footing you are going to design. We are going pad footing. Then just click on redesign. So you can see it will redesign here. If we change the size, let's see what happen. I am breaking this design and then I am just changing the size, reducing the size and depth also. just click on redesign. It will show revised site size is fails. So the RCDC gives the actual design size, so we need not to change. Or in case sometimes you have to resize in case of the overlapping, putting overlaps or some site issues, you have to change size. So for this I am resetting the value. If you have to increase or decrease the length of the footing, you just change the value. I am reducing the length and increasing the width. So let's check what happened. It failing, so we have to increase values. As you can see, this is the original size, and I have changed the size for my requirement, but this is for your reference only. I am not changing the value. I am resetting the footing and just designing. For I am keeping all the reinforcement. You can change the reinforcement here, such as I am keeping here. I am changing the values to 100 mm, so it will appear here. You can just accept it. It will appear here, your design for this footing, individual footing. In this way you can change or redesign all the footing, or also check in individual footing one by one. Here you can see some footings are overlapping each other. You have to design separately for combined footings. We are not seeing the combined footing today. We will make separate video for combined footing also. We can also check design calculations for the each and every footing. For this we have to go in reports, in design summary or design calculation. Design summary will show every footing and the summary of the design. As you can see, you can save this file also. And the next is design calculation. So we are going to see the calculation for FC29. Click on OK. As you can see, the detailed design for the footing number 29 will appear here. The codal parameters and all the values, the detailed calculation will appear here. You can check for which combination or for which loads the footing is designed. You can check here. And you can save this file also. Then next is, we cannot give all the individual footings sometimes in the drawing, so we have to group some footings. So for that, here is the option group or ungroup column. So we can group footings as per our grouping in our column file. So I am just showing you selecting some footing. Let's try with these 3 footings and just click. As you can see, these 3 footings are in group, so just click on. In this manner you can group all the footings as per your column grouping by clicking individual footings in the and creating the group. So click on OK. You can group before designing also, it will take less time, and you can see here the group is created. In this way you can group all the columns, so it will be easy to design and for the drawing also. Now we see some tabs. Here is one, view tabs. In view tab you can see the load cases, load combinations, and member forces. You can check the forces for each and every footing. The next is modify. In the modify you can change, as we have already seen the group and ungroup columns. The next is ignore column. Sometimes we have to ignore some columns, as we have to ignore these columns so that it will not appear in our drawing, as we will design this in combined footing. So just click and just right click on the column and click on ignore, or here in modify. So just I am clicking on ignore. You can see the color for this column is changed, and you can select the multiple columns and click on ignore. You can see these 4 columns are ignored by RCDC. This column will only appear in drawings, but the footing will not show on the drawing. Then next is rename. We can rename all the columns from top to bottom or bottom to top as per our requirement. Here is the footing mark manager. You can change the prefix as per your requirement. The next is grid lines and drawing style. You can change the drawing style also. Then next is reports. For going to reports, first we see how to save this file. First we need to see this plan. For that, here is the save option. You can click on this and then just save the file. It will save as DXF file. Give the name and it will show in the format of DXF file. You can check that file. Here the file is appeared. I am opening this file. As you can see, we have successfully saved the footing plan in DXF format. You can open this on AutoCAD. Then next is for schedule. For schedule, you have to just select the text schedule in the format you want. We will check both the formats. First is vertical format. As you can see, it will show in the vertical format, and the next is the horizontal format. You can see the schedule of footing. You can save this file also. First you have to save the project. Then just save. as footing schedule. You can open this file also in AutoCAD. The next is detail drawing. You can export the detail drawing for the individual footing or all the footings, as we just check for in one single footing, plan sections. You can change the drawing style also, so just click on OK. You can see here the plan for footing number 1 FC1 and the section 11 and 22. It will give the detailed section for the footing. You can save this file also in AutoCAD format. You can take all the sections for you want for each and every footing. And next is design. We have seen design calculations, but we have forget to check failure diagnostic. Then if we design or some footing not passing or failed, we can check the failure diagnostic here. In our case, there is no footing fail, so we will check this in our next video, how to check the failure diagnostic. Or in column also you can check, or in beams you can check the failure diagnostic for which case or which reason the footing is failed. The next is bill of quantities. If you want the BBS or BOQ for the footings, you can take the BBS also as per your requirements, or if you want to put the rates or some, or you just need just reinforcement weight, you can select here the reinforcement type wise and take the BOQs. In this way you can design footing in RCDC. So in our next video we are going to design beams in RCDC. Thank you.